decades, engineers have conquered mountains, spanned continents, and even built underwater cities. But somehow, a tiny 18-kilometer gap between Germany and Denmark has been impossible to bridge. But that changes now. Deep beneath the Baltic Sea, engineers are building something the world has never seen before, a tunnel so long, so complex, that for decades, experts thought it was impossible. This is the Fehmarn Belt Tunnel, a $7.5 billion engineering gamble that will connect Germany and Denmark in a way that's never been done before. Here's the shocking part. This tunnel isn't being drilled. Instead, engineers are assembling 89 gigantic concrete segments, each weighing as much as 13 Eiffel Towers, and then sinking them to the seafloor, piece by piece. This sounds insane, right? Well, it gets even crazier. This project has faced decades of political battles, environmental protests, and mind-blowing engineering challenges. Some experts even believed it could never be built. So, how did this impossible idea turn into reality? And what happens if something goes wrong underwater? Let's find out. For decades, travelers between Denmark and Germany relied on ferries to cross the Fehmarn Belt, an 18-kilometer stretch of water linking the Danish island of Lolland to the German island of Fehmarn. From the southern tip of Denmark, gazing across the Baltic Sea, the German coastline is visible. Yet despite its significance, ferry travel has long been a bottleneck. Unpredictable weather, endless delays, long queues, a simple 18-kilometer journey could take hours. So, something had to change. The need for a faster, more efficient connection became undeniable. The idea of a fixed link across the Fehmarn Belt has been debated for decades. Since the 1960s, infrastructure projects connected nearby areas, Fehmarn to the German mainland and Lolland to Zealand. However, it wasn't until the late 1990s that a direct connection gained serious traction. Initial plans proposed a massive bridge carrying both road and rail traffic, with early feasibility studies declaring it the best solution. By the early 2000s, the project took shape, designs, and proposals swirling on both sides of the strait. But in 2010, a crucial decision was made. An immersed tunnel would be a better option than a bridge. But why this shift? A bridge seemed the obvious choice, but as plans took shape, doubts began to grow. What if high winds made the bridge unsafe? What if it disrupted the delicate coastal environment? Then in 2010 came the game-changing decision. A tunnel would be the answer. But how do you build a tunnel? Under an ocean. And not just any tunnel, one built to last for generations, resistant to water pressure, shifting seabeds, and even earthquakes. The tunnel, built by submerging pre-constructed segments into a seabed trench, was deemed safer, more cost-effective, and better suited to the natural landscape. High winds, a major threat to bridges, would no longer be a concern, and its low-profile design minimized disruption to the region's scenic beauty. By 2011, the tunnel plan was officially approved and groundwork began. Today, this engineering marvel is taking shape, set to replace ferries entirely, slashing travel time across the Fehmarn Belt to just 10 minutes by car and 7 minutes by train. But this is just the beginning. The construction process starts with tunnel elements, each a colossal 93,000 tons, stretching 217 meters long, 42 meters wide, and 10 meters tall. These monolithic structures are crafted at a specialized factory in Denmark, spanning a staggering 1 million square meters. Steel rebar, the backbone of each segment, is meticulously cut, welded, and assembled at a dedicated factory. Before being transported to the casting area, high-strength concrete is poured with pinpoint precision. Climate-controlled production halls regulate temperature and humidity to guarantee unmatched durability. Each segment undergoes a 30 to 60-hour curing process, supported by specialized concrete batching plants, capable of producing 600 cubic meters of concrete per hour. But once complete, how do these massive structures float? Despite their immense weight, each segment is sealed with waterproof bulkheads, allowing them to achieve buoyancy, From factory, they glide into adjacent basins, which are enormous transition zones, bridging factory and sea. These basins are flooded and water levels controlled by massive gates. Tugboats then tow the segments into position for their final descent. The immersion process is a feat of precision. A 40-meter deep trench dredged along the 18-kilometer route, guided by advanced GPS technology, ensuring placement accuracy of just 15 millimeters. Once lowered into place, giant rubber gaskets clamp down, ensuring watertight seals between segments. A secondary membrane adds armor against water ingress. Temporary steel braces stabilize the structure before being removed, allowing the tunnel to adapt naturally to the crushing pressures of the deep sea. Finally, layers of gravel and protective armor lock the tunnel into the seabed itself. Safety is the beating heart of the tunnel's design. The two main tubes, one for each direction, stand isolated, slashing collision risks to near zero. Each tube hides an emergency lane, while cross passages linking road and rail tunnels carve out escape routes for survival. And if disaster strikes, the tunnel will be monitored 24/7 from dual control centers, with dynamic traffic signs and AI-powered eyes, guarantee a real-time response. But air is life for a tunnel like this. The primary airflow harnesses the piston effect generated by speeding vehicles, sucking fresh air through the tunnels like a colossal lung. Yet when traffic grinds to a halt, giant mechanical fans roar to life, pumping oxygen-rich air into the depths. However, such an ambitious project comes with monumental challenges. Coordinating construction across two nations demands meticulous planning and flawless collaboration. The Baltic Sea's fury threatens segment immersion and millimeter-perfect alignment. Managing a workforce of over 2,000, including temporary crews housed in purpose-built cities, also adds layers of complexity. Logistics challenges like raw material transport to precision production schedules demand constant vigilance. Yet against all odds, progress marches forward. The Fehmarn Belt Fixed Link is on track to open by 2029, a decade-defining triumph slashing travel time between Copenhagen and Hamburg from 4.5 hours to a mere 2.5, forging unprecedented connectivity between Scandinavia and the heart of Europe. By blending cutting-edge engineering with a commitment to sustainability, this project sets a new benchmark for large-scale infrastructure. It promises to revolutionize transportation, boost economies, and strengthen ties between nations. As the world watches, the Fehmarn Belt Fixed Link is poised to become a defining symbol of 21st century progress. If you enjoyed this video, don't forget to like, comment, and subscribe to Construction War, and turn on notifications for more updates.